Okay, so in this video, the second one of our study of hyperbolic trig functions. So we're just gonna kind of get used to some of those functions and evaluating them. And so I don't really need a calculator for this. I'm just gonna leave it in terms of e's or natural logs, or but just to kind of just get practice with the function. So the first one says evaluate hyperbolic cosine of 4. So if you look up at the definition, we know that hyperbolic cosine of x, it would equal e to the x plus e to the negative x all over 2. And so we can simply just input 4, right? So hyperbolic cosine of 4 is equal to e to the 4 plus e to the negative 4 all over 2. And like I said, I don't really need to do anything, to simplify anything, just remembering that, hyperbolic cosine has a plus here, hyperbolic sine has a subtraction, just to kind of get us familiar with those functions. Okay. Now, part B, hyperbolic tangent of natural log of 6. So similar idea, remember, we said that hyperbolic tangent is equal to hyperbolic sine over hyperbolic cosine. And then when you simplify that, you're going to get just the numerator part. So you'd get like e to the x minus e to the negative x, which came from the sine part. And then for the cosine part, we get e to the x plus e to the x. And again, that's simply because we have e to the x minus e to the negative x over 2. That represents the sine, the hyperbolic sine part. And then the hyperbolic cosine part would just change that to a plus. But then notice the 2's would cancel. So that's how we know that this is hyperbolic tangent. And then we substitute natural log of 6. So in this case, though, there is going to be some simplification because e and ln are inverses of each other. So we get e to the natural log of 6 minus e to the negative natural log of 6 over e to the natural log of 6 plus e to the natural log of negative 6. And so, well, e and ln cancel, so then we just have 6, and then minus a negative, so it becomes plus. I'm sorry, not minus a negative. We should simplify this negative to make it a fraction. So that's the same thing as e to the natural log of 1/6. Then I can simplify that to 1/6. And then this becomes 6 plus 1/6. There it is. And again, just the reason is because e and ln will only cancel if you isolate just the natural log function by putting everything else within within its domain. So then I would multiply by 6 over 6 just to kind of clear out this fraction. So that's 36 minus 1 over 36 plus 1. And so we end up getting 35/37. So it's sort of a nice number, relatively speaking, but that's because we were evaluating natural log of 6. Okay, now now it says, okay, hyperbolic inverse sine of 2. And so when I solve that, remember what it's saying is, okay, there's some x that 2 is equal to, e to the x minus e to the negative x all over 2. So that's what we're trying to find out, right? And so, well, we have the definition up there, in the next column where we say, okay, so, like the inverse hyperbolic sine is equal to natural log of x plus the square root of x squared plus 1. And so for now, we'll just use that definition, but maybe in the next video we could prove that as well. So we know that 2 is inputted into the function, so we get the natural log of 2 plus 2 squared is 4, and 4 plus 1 is 5. And same thing with hyperbolic secant. Notice the definition above. So we know that hyperbolic secant is equal to, just generally speaking, is equal to the natural log of the quotient 1 plus the square root of 1 minus x squared all over x. Okay, so then we put in 4/5. We end up getting the natural log of 1 plus the square root of 1 minus 4/5 squared, which is 16/25, all divided by 4/5. And we should probably simplify that a bit. So 1 minus 16/25 is 9/25. And that's actually pretty nice because the square root of 9/25 will end up being 3/5. And then divided all that by 4/5. 1 plus 3/5 is 8/5. So now we get the natural log of 8/5 divided by 4/5, which is actually really nice because the fifths cancel. So we get the natural log of 8/4, which is equal to 2. So it's kind of a cool little problem. And like I said, I'm not really requiring you to memorize the derivation of the inverses. Maybe I'll put that in as a supplemental video as well. Okay, and then a couple of identities, or at least one identity, and then one more problem. There's the definition of our inverses. So then, so it says, verify this to be true. Now, it sort of reminds me of the Pythagorean identity, right? That, x squared plus y squared equals 1. And in fact, if you remember our video, or the first page of the last video, I drew a hyperbola, right? Which was x squared minus y squared equaled 1. And so that any point on that hyperbola that satisfies this, equation, and I had claimed that x was, x was hyperbolic cosine and y was hyperbolic sine. So we're going to basically verify that that's true. And so, it's kind of like what we did, our proofs in pre-calc, last year. Last year it was. So let's go ahead and just maybe expand. What does it mean to be hyperbolic cosine, and then square that? So remember, hyperbolic cosine is e to the x plus e to the negative x over 2. So we're going to square that, and then we're going to subtract hyperbolic sine, which is e to the x minus e to the negative x over 2 squared. And so I'm claiming that equals 1. Well, when you expand that, you square the numerator, square the denominator. So in the top, in the numerator, we'll get e to the 2x, and then we'll get e to the x plus e to the negative x, and we'll get 2 of them. We'll get 2e to the zeros, because the exponents will add up and cancel. And then we'll get e to the negative 2x all over 4. And then minus, and when we square this term out, we will get another e to the 2x. We will get a minus 2e to the 0, and then we'll get a plus e to the negative 2x over 4 again. And I'm claiming that equals 1. Well, they already have a common denominator of 4. So now I can rewrite that as e to the 2x plus, well, that's a 2, plus e to the negative 2x minus that quantity of e to the 2x minus 2 plus e to the negative 2x, and all of that's going to be over 4, claiming it equals 1. Well, it looks like nice things are going to happen, right? Because e to the 2x will cancel with this e to the 2x. E to the negative 2x minus e to the negative 2x cancels. I get 2 minus a negative 2, which is 4 over 4, which, yes, is equal to 1. So this is sort of like the Pythagorean identity in a hyperbolic function. And again, it's going back to this idea that you don't have a circle. You don't have a circle that's establishing this Pythagorean identity. You actually have a hyperbola, right? X squared minus y squared equals 1 unit. So it's pretty cool. And you're going to find some bizarre, I don't know if bizarre is the right word, but some variations to things we know to be true. So, in normal trig, this is the relationship. But maybe in hyperbolic trig, because it's based on an exponential function, things are a little bit different. So the Pythagorean identity is one of those that we were so used to saying, oh, sine squared plus cosine squared is 1. Here, cosine squared minus sine squared is equal to 1. Okay, so then let's do one more example here. It says, hey, suppose the hyperbolic cosine is 5/4. Find the value of the 5 remaining hyperbolic functions. Well, because of the reciprocal nature, the hyperbolic secant would be the easiest to find. So hyperbolic secant of x would equal 4/5. So that's the first one. Now, we can actually get hyperbolic sine based on that identity right there that we just proved. We know that the hyperbolic cosine or cosh squared minus sinh squared of x is equal to 1. So if I know that the hyperbolic cosine value is 5/4, so if I square that, and I'm trying to find the hyperbolic sine, which remember we said we could call it sinh. Well, 5/4 squared is 25/16 minus hyperbolic sine squared is equal to 1. And so then if we want to solve this, maybe subtract the 1, add the hyperbolic sine. So 25/16 minus 1 is equal to hyperbolic sine squared or sinh squared. Well, 25/16 minus 1 is 9/16. So I'm going to then square root that. And technically I get a plus or minus, but since these are all positive values for our ratios with our starting ratio with e to the x, it'll be the positive root. So we get 3/4 is equal to the sinh. And once you know the sinh, you know its reciprocal. So hyperbolic cosecant of x would equal 4/3. So that's 3 of them. And then to get tangent, remember we can just divide sine by cosine. So then the hyperbolic tangent, there it is. So hyperbolic tangent of x would be the sinh of x, which is 3/4, divided by the cosh of x, which is 5/4. So that ends up being 3/5. And then our last one would be its reciprocal. So the hyperbolic cotangent would equal 5/3. So after this video, you should be able to solve and answer all of the questions that are in problem set 1. Which again, it's just your basic functions, getting used to their definitions, their inverses, and then establishing some identities. So that's that. The next video, we'll start doing some calculus with them. So we'll start taking derivatives as well as doing antiderivatives.